Conditional probability is a probability that event B occurs given that event A has occurred is called conditional probability. So conditional probability is essentially a type of probability that is conditional upon another event. So we write it as probability of B given A. So note that A and B are independent events if and only if the probability of B equals the probability of B given A, since the probability of event B does not depend on the occurrence of event A. So it gives you guys an example, and it says the table shows results of a class survey of 28 students. The question was, did you do a household chore last night? So they surveyed males and females and then recorded it. They said, yes, they did do a chore, or no, they didn't do a chore. So it says, find the probability of a student doing a chore. So probability of doing a chore. So that would be, yes, they did a chore. So we're going to add all the yeses, which is 7. Out of the total number of people that they surveyed, which was 28, and 7 plus 7 is not 7. 7 plus 7 is 14. So 14 out of 28 said yes, they did do a chore, which is 1/2 or 50%. So that was not conditional upon anything. That was just regular probability. What's the probability of the chore? So conditional is what they're asking in number 2. It says find the probability of a student doing a chore given that the student was a male. So this here, that second part, guys, when we write this, the probability of a chore given they are the male, that's the given. Also, the total you guys are using. So we're not asking the probability of a student doing a chore. We want to know, okay, what's the probability that they did a chore if they were a male? So how many males are there? 7 and 8, a total of 15. And how many of them said they did do a chore? 7. So 7 out of 15 is going to be your answer there, which is 47%. So you just have to be careful. What are they asking the probability of? Is it out of this group or that group? That's what it's conditional upon. So for number 3, find the probability of a student not doing a chore given that the student was a female. So that's your given, that's your total. So given that they're a female, there are 13 total females. And how many other females said they did do a chore? 7 out of... Nope, we're not doing chores, we're doing no chores. So how many of them said they didn't do a chore? That's going to be 6 out of 13, which is 46%. So that's it. Just be careful of what you're looking, what total or what group you're looking for, and then find what it gives you. That formula at the bottom of your paper, guys, it says conditional probability formula. This is if they don't give you the given. So when the given is not present, you have to calculate it. We're not going to worry about it, but I do want you guys to understand where they pull from. So like if you're not given a chart with all the information in front of you, you have to pull the information from what you know. So if you're talking about like a deck of cards or rolling a dice, those sort of things. So the probability of B given A is the probability of both of your events, so of A and B, divided by the probability of that second event, or of that first event that you're trying to find, A. So it goes through problem 3 with you guys, which we did using the chart. But if you guys are trying to find the probability of a female not doing a chore, so probability that they did not do a chore given that they were a female. So probability of A are all your females. Probability of B is not doing a chore. So probability of A and B is 6 over 28. That's this value right here. Then probability of event just A was that 13 over 28. So the probability that they were a female and not doing a chore was 6 over 28 over the probability that they were a female, 13 total females. So what happens when you divide by a fraction? You multiply by a reciprocal, which is right here. And that's how you, when you multiply, it reduces to 6 over 13, which is what we found. So again, you guys would have to use this formula if there's not a chart or if the given was not present. You would have to find it.